find the draw a box plot, find the class midpoint. We do a whole lot of things we have to do. So let's start. Grouped data. So we are coming back to grouped data. Grouped data. Grouped data. Grouped data. So the first thing we want to do is we want to read the given histogram, and we want to find the classes, and we go from there. We want to find the classes, the class midpoint. So we start. I'm going to put, this is the class, we'll make it class. All right, and here we shall actually write the frequency, of each class. We want to write the class midpoint of each class. We want to write the relative frequency. The relative frequency. And we want to find the cumulative relative frequency. So we're going to do all this cumulative relative frequency. So we are already given a data, and these are heights of students. See cumulative relative frequency. So this is CRF. Okay, so let's start from classes. We are writing the classes. They already gave us the classes. So from 56 to 58. This is the first class. And how many students are in this class? We can eyeball this and see that there are 5 students here. So the frequency, the number of students in that bar is 5 as frequency. The second class of this data is 59 to 61. The number of students is 20. If you look at it, number of students is 20, so the frequency is 20. Okay, the third class is 62 to 64. 62 to 64. The number of students, which is the frequency, is approximately 35. And by the way, there are 6 classes: 1, 2, 3, 4, 5, 6. There should be 6 classes because there are 6 bars. So we just had the third class. So the fourth class is 65 to 67. 65 to 67. And the tallest, the bar, has 40 students. The next class is 68 to 70. 68 to 70. The number of students is 25. 25. And the last class is 71 to 73. And the number of students is 10. So what I just did is called frequency distribution. These 2 columns are called frequency distribution. So anytime you're told to do frequency distribution, then all you need is the class and the frequency. So I just did the frequency distribution of this grouped data. After doing a frequency distribution, the next thing you want to do is find the total frequency. Find the total frequency. In this particular situation, we are dealing with a real world situation. So we are actually going to be adding how many students are in this, whoever is studying this, how many students are in this middle school, or how many students are used in this sample, because there may not be all the students there. Okay, so 5 plus 20 is 25. 25 plus 35 is 60. 60 plus 40 is 100. 100 plus 25 is 125. 125 plus 10 is 125 plus 10 is 135. So the total frequency or summation frequency is 135. So the next thing is to find what is called the relative frequency. The relative frequency is always the frequency of the class divided by the total frequency. Frequency of class divided by the total frequency. So for this first class, the relative frequency is 5 out of 135. In the next unit, this will be another way to ask you what is the probability that if you select a student at random, that student is from the first class. Okay, so has a height, because these are heights, has a height between 56 and 58. Okay, so so relative frequency is the same as probability. Relative frequency and probability are the same. So in unit 2, we shall change the name from relative frequency to probability. All right. So what is the relative frequency of the second class? It is the number of students in the second class divided by 135. The relative frequency of the third class is the number of students in the third class over 135, which is the total number of students. So remember now, the relative frequency is the frequency of the class over total frequency. So what is the relative frequency of the fourth class? 1, 2, 3, 4. So the relative frequency of the fourth class is 40 over 135. Okay. Now, what is the relative frequency of the fifth class? The frequency of the fifth class divided by the total frequency. So 25 divided by 135. What is the relative frequency of the last class? It is the frequency of the last class divided by the total frequency. So that is 10 divided by the total frequency. Okay. Now, for now, let's do the cumulative relative frequency. The cumulative relative frequency is the frequency of the class plus the frequency above. Well, right now, the first class has nothing above. Therefore, the cumulative relative frequency of the first class is 5 out of 135, the same as the relative frequency. The cumulative relative frequency of the second class is 5 plus 20, which is 125, which is 25. 25 out of 135. So we are accumulating or less. The cumulative relative frequency of the third class is the frequency of the third class plus all the frequencies above it. So the relative frequency of the third class plus relative frequency of the second class plus that of the first class. Okay, so now I have, if I add them up, I'll have 60. So the cumulative relative frequency of the third class is 60 over 135. All right. The cumulative relative frequency of the fourth class is the relative frequency of the third class plus all the relative frequencies smaller than that, and that is 100, because if I add 40 to 60, 100 over 135. What is the cumulative relative frequency of the fifth class? 25 plus 100. So that is 125 over 135. 135. What is the cumulative relative frequency of the last class? The cumulative relative frequency of the last class is always going to be, if I add this, I will have total over total. 135 divided by 135. Okay, 135 over 135. Okay, so now we have, which is the same as 1. Therefore, the cumulative relative frequency column is complete. We can now find the cumulative relative frequency. So remember that the cumulative relative frequency of the class, of any class, is the relative frequency of this class plus the ones above it. Okay, it's time now to find the class midpoint. So what is class midpoint? Class midpoint, the class midpoint is lower class limit plus upper class limit divided by 2. So lower class limit for the first class is 56. Upper class limit for the first class is 58. Add them together and I divide by 2. So when I add this together, I have, notice that I have 6 plus 8 is 14. So I have 114. So 114 divided by 2. So I will have 7. See, I have 114 divided by 2. So to go into 11, I have 5. To go into 14, I have 57. So the cumulative, the class midpoint is 57. The class midpoint is 57. So the class midpoint of the first class is 57. So what is the class midpoint of the second class? The same thing, 59, lower class limit plus upper class limit divided by 2. So I have, if I add them up, I actually have 1 plus 9 is 10. So I have 10. And then I have 120. 120 divided by 2. When I divide 120 by 2, I have 60. So I got 60 here. So the next class midpoint is lower class limit plus upper class limit divided by 2. But wait, let's see. What is the class weight? I'm going to get another pen. What is the class weight? The class weight is the distance between consecutive lower limits. 59 minus 56 is 3. 62 minus 59 is 3. So note that the class midpoints differ by class weight. So all I need to do is continue this by adding 3. So I will just add the class weight to continue, because now I found out that the class weight is 3. So I can now say the next class midpoint is 63. The next class midpoint is 63 plus 3 is 66. The next class midpoint is 69. And the next class midpoint is 72. Okay, and you can check it to see. You will notice that the class midpoints differ by the class weight. So what is the class weight? The class weight is the distance between consecutive lower limits or distance between consecutive upper limits. So now we have completed a group data table. Now we can do a whole lot of things with this. We can be told to find the 5-number summary of this group data. When I'm told to find the 5-number summary of this group data, now it is easy, because what I have to do is I know the frequency, I know the class midpoint. So what I have to do is get the class midpoint and put it in my calculator. So I'm going to get the class midpoint, put it in my calculator. All right, so the next question is find the 5-number summary. Find the 5-number summary of this data. So what I'm going to do is pull up my calculator to find the 5-number summary. When I get the 5-number summary, I will draw a box plot also. So get the 5-number summary. Okay, I'm going to clear. I am pulling my calculator up. So if you are just joining this class, we are doing grouped data. We are doing group data. We want to find the 5-number summary of a grouped data. All right, so now I am going to pull up this data again. So I have the group data, and I have the frequency distribution, the class midpoint, the relative frequency, and the cumulative relative frequency. So I have everything. Now the next thing is draw a box plot and find the 5-number summary. Draw a box plot of this grouped data and find the 5-number summary. So what you do whenever you are given a group data to find the 5-number summary is go to Start, Edit, and then put in the class midpoint in L1 and frequency in L2. So in other words, the first list is your class midpoint. The second list is your frequency. So 57, enter. The first class midpoint, 60, enter. That's the second class midpoint, 63, enter. 66, enter. 69, enter. 72, enter. Okay, so then go to the next one. The next L2 is where I put the frequency. I am told to find the 5-number summary of the group data. So the class midpoint is the class representative. The class midpoint is the class representative. So because the data is already grouped for me, there's no way I can recoup the original data. So I must put in the class midpoint. So the first class midpoint represents the first class. The second class midpoint represents the second class. The third class midpoint represents the third class, and so on. Now the next thing is putting the frequency in L2. So the first frequency, or the frequency of the first class, is 5. The frequency of the second class is 20. The frequency of the third class is 35. The frequency of the fourth class is 40. The frequency of the fifth class is 25. The frequency of the last class is 10. When you finish putting the frequencies, you better have both of them on the same horizontal line. The last frequency must be on the same horizontal line with the last class midpoint. Otherwise, it means you enter the wrong data, and you really want your data to be correct. All right. So now that you have entered L1 class midpoint, the first class, L2 frequency, you are ready to do one variable start of a grouped data. So let's do one variable start of a group data. So go to Start, arrow to Calc, do one variable start, and this is a grouped data. So the class midpoint, which is the class representative, is in L1. Do you have frequency this time? Yes. I have frequency because this is a group data. And where is the frequency list? It's in L2, second L2. So we calculate. Okay, so X bar is 65. That is the mean, but we're not told to find the mean. But this is one variable data. You can find anything. You could be told to find the sample standard deviation. You could be told to find the population standard deviation. You could also be told to find the sample variance, population variance, depending on what you're looking for. But at this particular time, we are told to find the 5-number summary and draw a box plot. So now I have the 5-number summary. I can see it here. The question could be find the you could be told to find the range, and you can be told to find the range, and you find the range. If you are told to find the interquartile range, it is Q3 minus Q1. Okay. Okay, so right now I am going to draw the box plot. I have the 5-number summary. I have it here, and I copied it. So ready to draw a box plot. All right. So now I want to draw a box plot of this data. So I'm going to draw a box plot right here. This is a sketch, so this box plot is just a sketch. Okay, now I have all the data. I have everything I need to draw this box plot. So the maximum number is 72. So 72 is the maximum number right here at the end of the tail. The minimum number is 57. The first quartile, which is at the left tail of the box, is 63. So this is Q1. Q1 is 63. And this is Q3. Q3 is 69. The median is 66. The median is somewhere in the middle. It may not be in the middle, but the median is 66. And the median is Q2, the second quartile. Let's just write it here. So this is Q1, first quartile. This is Q2, second quartile. This is Q3, third quartile. So now I have drawn the box plot of the data. So this is the box plot of this data, box plot. When you can also be called a box and whisker plot. If you can be also be told to find the interquartile range. If you are told to find the interquartile range, IQR, the interquartile range is Q3 minus Q1. The interquartile range is Q3 minus Q1. So if the question says find the interquartile range, then it is Q3 minus Q1. If it says find the range, it is maximum minus minimum. You know how to find that already. Now, you could be told to find the mean also. If we are told to find the mean, we go back to the question. We go back and pick up, see what our calculator says about the mean. So I got my calculator somewhere here. So let me pull my calculator up again because I think it disappeared. So I'm going to get my calculator and find the mean of that data. So let me go to start. I want to go to VERS statistics, number 5. See if I can still see. Okay, and I'm looking for the mean of that data, and the mean is X bar number 2. Let me see if the data is still there. If I hit enter, I want to see if that data is still there. So let me see, VERS statistics, which is number 5. Is this still there? Or did I miss it? Is it cleared? Okay, so it's cleared. That's why it's saying go to. So that means let me go back. I'm going to go back and see why. Oh, the data is cleared. Okay. All right. So the data is cleared because, all right. And all I have to do is put the data in and then find the mean. Do one variable stat. We already did one variable stat and we found the mean, found the 5-number summary. We can actually go ahead and put the data in again because really I want us to make sure we understand this since our test is coming very soon. Okay, so because the data is cleared, I want to actually go back and put it in again so that I can find the mean, compare it with the median, see if the data is skewed or bell-shaped, conclude whether there is a bell-shaped data. Okay, and so remember that if it's actually good that if I do it again. So anytime you have a group data, you have and you have class midpoint. Class midpoint is the class representative. So what you do is put in the class midpoint in list 1. And then When you finish, I'm putting it in now, the class midpoints in list 1. So all the class midpoints are in list 1 now, and I'm going to put in the frequency in L2. So the frequency of the first class is 5, frequency of the second class is 20, frequency of the third class 35, frequency of the fourth class 40, frequency of the fifth class 25, frequency of the last class is 10. Okay, so now that we have the class midpoint in L1 and frequency in L2, we can do one variable data again, one variable stat. So go to stat, arrow to calc, one variable stat, and then L1 is my class midpoint. Whenever you have a group data, the class midpoint has to be the first list. Then the frequency will be the second list. So second L2 to put the frequency in there, because I have a frequency list. I'm going to calculate again. Okay, so the mean is 65. And then if we arrow down, we will see all the things we had before. So they are still the same. We can be told to find the mean. So the mean we found is 65. The mean is 65. The median is 66. So the median is slightly greater than the mean. We can say that this data is approximately normal. But because you did statistics, if median is slightly greater than the mean, you say that the data is slightly skewed left. Slightly skewed left. Okay, so when the mean is less than the median, data is skewed left. Okay, and so now mean is less than the median, 65, and median is 66. Okay, and the next one is, if I'm told to find the standard deviation and variance of this data, suppose this data is a population. If I'm told to find the standard deviation and variance, what you have to do, we're going to repeat it even though we did it before. So now we have found the one variable stat of this data. I'll go to stat, and then I will 5, and then I am going to find the standard deviation. The standard deviation is, and then when I pull it down, that is the sigma x standard deviation. If I square it, it is variance. So standard deviation squared is variance. Standard deviation squared is variance. So now I found the variance of this data. The variance is 14. The standard deviation is 3.742. If you are told to find the standard deviation, you will be told maybe the number of decimal points. So 3 decimal points, I have 3.742. Okay, now I have a standard deviation and variance of this data. I can be told to find the interquartile range. If you have 5 number summary, you can get the interquartile range. The interquartile range is Q3 minus Q1. So 69 subtract 63 is 6. Therefore, the interquartile range is 6. Okay, so this gives us everything we need to know about this real world data. Let's go up and see again what the real world data is talking about. It says, so this data is saying that use the histogram to determine the probability that a student chosen at random from Hammond Middle School will be 59 to 61 inches tall. Okay, 59 to 61 inches tall. Remember I said that probability is the same as relative frequency. So let's look at the class 59 to 61. So second class, find the probability. Let me get another color. So find the probability. So we already found it. What is the probability that a student chosen at random has a height between, is that height or weight? Between 59 and 61 in this Hammond Middle School. So that probability is the frequency of the class over total frequency. So it is the same as relative frequency. So the probability is 20 over 135. Remember that probability can be in decimal or fraction. So what you do is, if you're told to leave your answer in fraction, so that probability will be, you can simplify this, divide 20 by 5, you have 4, divide 135 by 4, actually by 5, you have 27, so you have 4 over 27. Okay, but suppose you're told to leave your answer in decimal, 3 decimal places. What is the probability that a student chosen at random is in the second class? All right, that probability to 3 decimal places, 20 divided by 135. Remember that probability is the same as relative frequency. Probability is the same as relative frequency. Also remember that probability cannot be more than 1. It has to be between 0 and 1. Therefore, 0.148 is the probability. The probability that a student chosen from Clarion Middle School, the height is between 59, the height of the student is between 59 inches and 61 inches. That probability we have as 14.81%. Remember that probability can be in percent or decimal. Probability can be in percent or decimal. So in this section, we covered group data, how to find the class midpoint of a group data, how to read frequency distribution and collect the frequencies, how to find the relative frequencies, how to find the cumulative relative frequencies, how to find the interquartile range. The interquartile range IQR is Q3 minus Q1. So actually, when you do one variable stats, you can find the 5-number summary, you can find the range, you can find the interquartile range, okay? And then you remember that when you're given a group data, you haven't lost everything. You can use the group data to find the 5-number summary. So make sure you find them. So the next thing we want to find now is class boundaries. Remember, we have also found the class weight. We have found the class weight. The difference between consecutive lower limits is the class weight. And the difference between consecutive upper limits is the class weight. So the class weight in this distribution is 3. Okay, so suppose I'm told to rewrite the classes with class boundaries. What do I do? So this is what I'm going to do. If I'm told to rewrite the class boundaries, the classes, instead of using the class limits, I should use the class boundaries. So to use the class boundaries, I want to rewrite with class boundaries. So I will now use class boundaries here. Class boundaries. So how do I find class boundaries? How do I find the class boundaries? When I'm given the class limits, so this is the lower class limit in the first class. The lower class limit of the first class is 56. The lower class boundary is 55.5. So 55.5 to the upper class boundary of the first class is 58.5. 58.5. The lower class boundary of the second class is 58.5, and the upper class boundary of that second class is 61.5. So I'm rewriting this frequency distribution with class boundaries instead of class limits. I could be told to do that. The lower class boundary of the third class is 61.5. In other words, drop the lower limit by 0.5 and add the upper limit, add 0.5 to the upper limit. So 64.5. So what is the lower class boundary of the fourth class? Okay, so the limit is 65. Therefore, the lower class boundary is 64.5. And by the way, you want to make sure that they are the same. See? And then the upper class boundary of the fourth class is 67.5. 67.5. So I'm rewriting the classes with boundaries this time. For the fifth class, the lower class boundary is 67.5. The upper class boundary is 70.5. For the last class, which is the sixth class, the lower class boundary is 70.5 and the upper class boundary is 73.5. Okay, so notice that if you find the difference between consecutive lower limits, 58.5 minus 55.5, if you check it out, you have almost the same thing. So the difference between consecutive lower class boundaries are going to be, there won't be much different. Okay, so so you notice that the difference between consecutive class boundaries will still be the class weight. Difference between consecutive class boundaries is still the class weight. Okay, difference between consecutive lower limits is still the class weight. So it doesn't really matter whether you are using class boundaries or class weight. I want you to make sure you know. You need to know which one is weight. These are class weights. These are class boundaries. The second one, this one are class boundaries, and these are class weight. Okay, the difference between consecutive lower limits are still going to be the same. So let me know if you have any question. Let me know if you have any question on this. We have been talking about group data We covered class boundaries, class weight. We covered uh, class weight, and then class limits, class midpoint, relative frequency, cumulative relative frequency. We found the interquartile range. We did a box plot of a grouped data. So actually, this is when we start reviewing, we'll come back to this video because I'm recording this. I am recording this. When we start reviewing, we'll come back to this video. Okay. Let me know if you have any other question. We found the variance. We found the standard deviation. We know how to put it in our list. Okay. Let's go to one more question about finding the, so let's go back to this one more question, and we want to find the minimum and maximum values, the Q1, Q2, Q3 for the following data, then use these values to draw a box plot, a Buck and Whisker plot. Oh, well, we're going to do this again because we are actually doing it now, so that next class we'll start reviewing for test number 1. We start reviewing for test number 1. Okay. All right, so let's go put it in. I am going to clear L1 and L2 because I don't need them anymore. All right. I don't need to do that anymore. So I am going to do number 21. So the data here is a raw data. This time I have a raw data. So I am going to put the data in L1. I don't have frequency this time. 33, enter. 39, enter. 41, enter. 31, enter. 36, enter. 44, enter. 22, enter. 40, enter. 46, enter. 33, enter. 41, enter. 48, enter. 37, enter. 33, enter. 26, enter. Okay. Now I have this data here. I'm told to find the minimum number and maximum number. Because I'm asked to find the minimum and maximum number, I have to sort the data in ascending order. So I'm going to go to start and sort ascending, so I can arrange them in ascending order. Data is in L1. I am going to hit enter. Okay, I need to put L1 in there, not 1. Data is in L1, second L1, close parenthesis. I hit enter. And let's see if it is sorted in ascending order. So we want to see, is this sorted in ascending order? Yes. So the minimum number is 22. Let's see what the maximum number is. The maximum number is 48. Therefore, the range is 48 minus 22, and that is 26. So we already found the minimum number, the maximum number, and then we know the range. But we're not done with the question, because the question says draw a box plot. In other words, find all the quartiles. For me to find all the quartiles, I need to do one variable start. So go to start, arrow to calc, do one variable start of the data in L1, So I'm going to make sure that I don't have L2. So I'm going to clear. Make sure I don't have L2. Calculate. All right, so the 5-number summary here. The 5-number summary is maximum number 22, first quartile 33, the median is 37, third quartile is 41, maximum number is 48. So, but we needed the quartiles because we have already found the minimum number, maximum number. All right, so now that I have the 5-number summary, I can now that I have the 5-number summary, I can draw the box plot, which they asked me to draw. So I'll come over here and draw the box plot. All right, so I'm just going to draw a box plot. This is a box plot that is not so this is the minimum number. This is the first quartile. Second quartile will be somewhere here. Second quartile is the same thing as the median. Second quartile is the median. And this is the third quartile, which is Q3. This is the maximum number. Okay, so and I already have this 5-number summary. So the minimum number is 22. The first quartile is 33. The median is 37. The third quartile is 41. And the maximum number is 48. So I have all of them. They might ask me to find the interquartile range. The interquartile range is Q3 minus Q1. And Q3 minus Q1 right here is 41 minus 43. So 41 minus 43 will give me approximately 8. So what is 41 minus 43? So we have 8 there. So we have 41 minus 43. 41 minus 33, sorry. 41, take away 33. And I have 8. Okay, so that is the interquartile range. The interquartile range is 8. So I have answered the question. So at the end of this day, after watching this video, you should be able to draw a box plot. It's already in the test. Our test is going to be on the 16th. So we should start reviewing next week. Our review starts next week. When you watch this video, if you're not in class, ask any questions you may have. But if you watch it the second time, you notice that I covered everything that you needed to hear: how to find the class boundaries, how to find the class midpoint, how to find the relative frequencies, how to find the cumulative relative frequencies, how to draw a box plot of a group data, how to recoup classes from a histogram. So we covered a whole lot about group data. So go back and watch this video. Let me know if you have any questions. All right.